Hello and welcome to the fourth probability video, and in this we're going to look at relative frequency, and we're going to be comparing how many times outcomes of an event have happened. So let's have a look then. The dice was rolled 300 times and the numbers appeared this many times each. So 1, there were 42 of them, 2 were 48, there were 33 threes, etc. And we're going to calculate the relative frequency of each of the numbers. So let's get a close-up on the table. And there were 42 ones out of 300, so the relative frequency of landing a 1 was 42 divided by 300. Now 42 divided by 300 is 0.14, and this is also often called the experimental probability. So that's the probability of landing a 1 with this dice based on an experiment we've done where we've repeated the rolling 300 times. So let's have a look. 2, there were 48 out of 300. 48 divided by 300 is 0.16. So that's a relative frequency, 0.16. It's also known as the experimental probability. So 3, there were 33. Now 33 divided by 300, 0.11. Now 4, there were 84 of them. And if you divide 84 by 300, again we divided by 300 because that's how many rolls we had. And that's 0.28. So we notice that's a lot higher than the other ones. 5 comes out with a relative frequency of 0.13, and 6, 0.18. So we've worked out all the probabilities of each of the number. And what do you get if you add up all of those probabilities? Well, remember the total probability must be 1, and if you add those up, you do get 1. Okay, what can you say about the dice? Well, actually, if you look at 4, the probability again of 4 is 0.28. That's much higher than the other numbers. So we would say that the dice is biased or unfair. Let's have a look at a part of an exam question where we've got to calculate the relative frequencies. And this is a little bit more complicated because this is the cumulative number of sixes. So let's have a close-up on the table. So okay, it says there the cumulative number of sixes thrown. Now what that means is for the first 10 throws he had 4 sixes. That's where that 4 comes from. For the first 20 throws there was a total of 4 plus 3, or in other words 7 sixes. For the first 30 throws it's 4 plus 3 plus 2, which is 9. For the first 40 throws 4 plus 3 plus 2 plus 3, which is 12. And so on. Now we need to work out what the number of sixes was for the first 80. So we add up all those and we get 24. It's actually probably a bit easier if we just say, okay, for the next one, there's actually, there were 3 more and we had 24 up to 80. So the number of sixes must be 24 plus 3, 27. And over the 100 throws, well, between 90 and 100 we did 10 throws and we got 2 sixes. So in other words, 27 plus 2, total of 29 sixes over 100 throws. Now we've got to work out the relative frequency of throwing a 6. So when we did it 80 times, the relative frequency was 24 divided by 80. When we did it 90 times, 27 divided by 90, and 100 times, 29 divided by 100. Now we need to change those to a decimal. So 24 80ths. You might notice you can divide top and bottom by 8, and we get 3/10, which is 0.3. 27 90ths, you might notice you can divide the top and bottom by 9, and that gives us 3/10, which we know is 0.3. And there's the last one there, 0.29, because 29 hundredths is 0.29. So there we are, we've worked out all of the relative frequencies from that table. Now, over to you to have a go with the exercise, and good luck with that, and I'll speak to you on the next video.